Have you ever really stopped to think about how we get a bar of pure, gleaming gold from just a regular old chunk of rock? It's this incredible journey that's part brute force and part, well, seriously clever chemistry. And today, we're going to break it all down. So yeah, this is the big question, right? How in the world do you take this rugged, unassuming piece of ore and turn it into this, a brilliant, heavy bar of almost pure metal? The secret isn't just about finding the gold, it's about convincing the rock to finally let it go. All right, so our journey starts not with some delicate chemical process, but with pure, raw power. This first stage is all about the physical stuff, breaking down massive rocks into something we can actually work with. First, these giant crushers just obliterate the raw ore into smaller, much more manageable pieces. Then, that crushed rock gets fed into these enormous rotating mills along with a bunch of water. Think of them like giant superpowered washing machines that grind everything down into a fine, sandy paste. And finally, cyclones spin that mixture around, separating the really fine stuff from the coarser bits, which, you guessed it, gets set right back for another round of grinding. The whole point of all this is to create a fine, watery mud that we call a slurry. There's a really important word for what we're doing here: liberation. The whole reason we're grinding this stuff into dust is to achieve liberation. We're not just making small rocks, we are grinding them down so incredibly fine that the microscopic little specks of gold hidden deep inside are finally exposed to the open. Because let's face it, our chemicals can't do their job if they can't actually touch the gold. Okay, so now that our gold is liberated, we can start what I like to call the chemical heist. This is where things get really cool. We use some amazing chemistry to make solid gold literally dissolve and disappear into the water of that slurry. But before we can do that, we have to set the stage perfectly. First, we add lime. This raises the pH, and it's an absolutely critical safety step to make sure we don't create any dangerous cyanide gas. Then comes the main event, sodium cyanide. That's our key ingredient. And finally, we start bubbling air through the whole mixture because, believe it or not, this entire reaction absolutely needs oxygen to work. And this, right here, is where the real magic happens. The slurry slowly moves through a series of huge tanks over many hours. And during that time, the cyanide and the oxygen work together, plucking those tiny solid gold particles and pulling them into the solution. The gold becomes a gold cyanide complex, totally invisible in the water, but it's there. So now we've got a bit of a problem. Our gold is in there, but it's dissolved in literally thousands of tons of muddy water. How on earth do you get it back out? Well, you need a very special kind of tool, something that can go in and fish out those individual gold molecules with incredible precision. And here's our hero: activated carbon. The best way to think about this stuff is as a magnetic sponge, but for gold. Activated carbon has this ridiculously huge internal surface area, and it has a really strong chemical attraction to that gold cyanide complex we made. So as the slurry flows past these little carbon granules, they just snatch the gold right out of the water. It's amazing. Now, plants usually do this one of two ways. You've got carbon-in-pulp, or CIP, where you let the gold dissolve first, and then you add the carbon sponge to grab it. The other method is carbon-in-Leach, or CIL, where you do both at the same time in the same tanks, so you're dissolving and capturing the gold simultaneously. But honestly, either way you do it, the end result is exactly the same. The gold ends up stuck to the carbon. All right, we've done it. We've captured the gold on our carbon sponges. Now for the really exciting part: getting it off the carbon and turning it into something we can actually see and hold. It's time to forge the doré bar. To get the gold back, we basically just have to reverse the chemistry. We take that gold-loaded carbon and move it to a special stripping circuit. There, a hot caustic solution washes over it and forces the gold to let go. We are literally wringing out that golden sponge, concentrating all the gold we collected from tons and tons of slurry into one small batch of super rich liquid. It's such an elegant process when you think about it. We used chemistry to make the gold dissolve, and now we're going to use electricity to turn it back into a solid. That gold-rich solution gets pumped into what are called electrowinning cells. In there, an electric current makes the gold plate out onto steel cathodes, forming this thick, metallic sludge. And finally, the moment we've all been waiting for: the pour. That sludge is scraped off, it's mixed with some chemicals called fluxes, which help separate out impurities, and then it's melted in a furnace at insane temperatures. Then it's poured into a mold, and what comes out is a doré bar. It's a semi-pure bar of gold and silver that's now ready to be shipped off to a refinery for that final purification. But wait, the story doesn't actually end with the pour. A modern gold plant is designed to be a closed loop. It's not just about making gold. It's about reusing your key materials and managing all the waste responsibly. It's about bringing the entire process full circle. So what happens to our carbon sponge after we've wrung all the gold out of it? We don't just throw it away. No way. It gets a nice acid wash to clean off any mineral gunk. Then it's roasted in a kiln to burn off any other junk that's stuck to it. After that, it's basically good as new, and it's ready to go right back to work capturing more gold. And what about that leftover slurry, the stuff that still has some cyanide in it? Before that can go anywhere near a tailings facility, it gets sent through a detoxification process. This is a hugely important step that neutralizes the cyanide, making it safe for storage and making sure the plant is meeting really strict environmental rules. So, do they get every single speck of gold? Is recovery 100%? Absolutely not. In the real world, metallurgists are dealing with constant challenges. Sometimes the ore is refractory, which means the gold is chemically locked inside other minerals where the cyanide just can't get to it. Other times, the ore has its own natural carbon in it that pregrobs the gold. It steals it from the solution before our own carbon can grab it. It's this continuous battle against the chemistry of the rock itself. So there you have it. The journey from a simple rock to a gold bar is just an unbelievable feat of chemistry and engineering. And it really makes you wonder, doesn't it? What other materials that you use every day? You know, the aluminum in your can, the silicon in your computer chip. What other materials have a hidden story that's just as complex? Thanks for joining.